These examples definitely take a long time, so we're going to make a lot more short videos here instead of a bunch of long ones. I got a problem right here. It says solve the following differential equation and determine the interval of validity. So what I have is, I got split up, y prime equals 6y squared x. So y prime equals 6y squared x. Okay. And oh, by the way, y of 1 equals 25. So this is an initial value problem here. Getting going is fairly straightforward here. I have dy dx is equal to 6y squared x. So let's go with dy over y squared is equal to 6x dx. You can move the 6 and wherever you want to. So long as all the y's are here and the x's here, the 6 can go either place. I tend to not give myself fractions if I can afford it. Can afford not to. Okay, so I have, let's see, integrate both sides, and I get negative 1 over y equals 3x squared plus c. Okay, now on this problem, I definitely need to solve for y. Okay, I can solve for y, but let's just all be clear on how we do it. First of all, this negative bothers me, so let's fix that up. So I have 1 over y equals negative 3x squared. You could say plus c here or minus c, whatever you want, just plus c doesn't matter. And then finally here I have y. If you reciprocal one side, you reciprocal the other side. I have 1 over negative 3x squared plus c. Now I think actually at which stage it was easiest to plug in stuff and find the initial condition. I actually think it was probably way back in the beginning rather than right here, but you know, whatever. So I have y of 1 is equal to 1 over negative 3 plus c, and that's equal to 25. A little trick one of my teachers taught me a long time ago was that 6 over 3 is equal to 2. And so you take those two things and flip them. So 6 over 2 equals 3. It's called a fact family. So anyway, 1/25 is equal to c minus 3. So c is going to be 1/25 plus 3. And what's that? 75/25. So that's 76/25. Very good. So my function is y equals 1 over negative 3x squared plus 76/25. If you had done minus, just pay attention to whatever symbol you had here. So whatever, if you had plus, then make sure you go back to the right one. Okay. Okay. It's probably worth cleaning up here. So I'll multiply top amount by 25. I get 25 over negative 75x squared plus 76. All right, so there's my y function. Now, what's this interval of validity all about? Okay. Notice that this thing right here is a quadratic. Okay, and that quadratic we can see it's a parabola opening down, shifted up. Okay, so I know right off the bat that denominator thing has a graph that looks like this. Okay, it is going to be 0 2 times, and so the domain is going to be this stuff or this stuff or this stuff. And what the interval of validity is the interval which contains x equals 1. Okay, that's the interval on which this particular function is valid. Okay, I'm going to leave that to you because it's just a quadratic and I ran out of space. But that's all that's happening here. Is I got to find where this function is defined. This function has 2 vertical asymptotes. The y function, that is, has 2 vertical asymptotes, and it's only going to be good in the location where we have y of 1 is 25. Okay? All right, let's go on to the next one. So let's solve the initial value problem. Dy dx equals 3x squared plus 4x minus 4 divided by 2y minus 4. Now this is fairly easily separable, but you can see I left you a lot of space because this one's going to take a lot of work. I have 2y minus 4 dy equals 3x squared plus 4x minus 4 dx. And even integrating is pretty nice on this one. So I have y squared minus 4y is equal to x cubed plus 2x squared minus 4x plus c. Okay. And what are we to do here? Now it appears at first that I'm not going to be able to solve for y, but in fact I can, because this thing has an initial condition. And so what are we going to do with that? Well, let's just plug that in right now so that we can get the mystery c out of the way. So y of 1 is 3 means that the x is 1 and the y is 3. So let's plug all those in. So I have 3 squared minus 4 times 1 is equal to 1 cubed is 1 plus 2 times 1 is 2. 4 times, oops, that's a 3 and a 1, sorry. 4 times 1 is 4 plus c. And so 9 minus 12 is negative 3 equals, okay, so that's going to be 3 minus 4 is negative 1. Add 1 to both sides and I get negative 2 is c. There we go. Good. So what I have is y squared minus 4y is equal to x cubed plus 2x squared minus 4x minus 2. Okay, now this is an implicit solution, but do I actually have an explicit solution? And the answer actually is yes. I need to solve this for y, and you can do a couple different techniques here. I think the easiest is just going to be to complete the square, but you could treat this as a quadratic where all of this stuff was the c. If that sounds terrifying, it's because it kind of is. So let's just go ahead and complete the square. B is negative 4, so I'm going to add negative 4 over 2 squared. So b over 2 squared gives me y squared minus 4y plus 2 is equal to x cubed plus 2x squared plus 2. Doing math while you're writing on an iPad is difficult. Doing arithmetic. 4, there we go. Minus 4x, and I'm going to add 4 to this side, so minus 2 plus 4. The left-hand side is now y minus 2 squared is equal to x cubed plus 2x squared minus 4x plus 2. And we can do 2 steps in once here. We're good at this. So we'll take the square root of both sides, and so y is equal to plus or minus the square root of all that stuff, x cubed plus 2x squared minus 4x plus 2. I said I was doing 2 steps at once. Let's also add 2 to both sides, and so have that 2 on the outside of the square root. Now, you're thinking, that's not a function. You said that this is supposed to be a function. Well, it is. We actually can figure out whether it is the plus or the minus because I have an initial condition that was y of 1 is 3. It's not plus or minus, it's just one of them. Okay, so when I plug in y of 1, I have to make sure that I get 3. Now, what are we going to do here? So I actually don't need to do anything. I actually don't need to do this. I can tell just by looking at it. So this whole thing here on the inside, this root thing is going to give me a positive, and I'm going to add 2 to it, and it's supposed to give me 3. So can I take a positive number, make it negative, and add 2 and get 3? And the answer is no. Okay, it's got to be the plus. This whole root thing, when you plug in 1 here, you're going to get root 1, and root 1 is going to give you 2. So root 1 plus 2 is going to give you 3. And so I know that the actual solution is the square root of x cubed plus 2x squared minus 4x plus 2 plus 2. A little bit of eraser there. There we go. Okay. So that's how we clean that one up. And we're actually going to be able to find a unique function that satisfies our differential equation and our initial condition. So when we have initial conditions, there's going to be an explicit one. And so we're going to be able to resolve any kind of non-functiony stuff that happens along the way. Okay. Now I've done quite a few of these here, And usually what I do in class is I have students work on a few things. So maybe I'll just kind of give you a hand starting with this one, and then I'm going to let you try them, and we can post the solutions and talk about them on Zoom here. So as we think about trying to separate stuff, pluses and minuses tend to screw things up as far as separability is concerned, because I need it to be a function of x times a function of y. And so the way we have to do this is you have to factor out the e to the minus y, and then you get 2x minus 4. And so that is much easier to separate. So I'll let you finish that one. Same thing goes with this one here. What to do with the e to the y minus t? Well, I need to write this as a product of stuff. So that is going to be e to the y on top, e to the t on bottom. And then I'm going to write t, not that. I'm going to write 1 plus t squared on top. And the secant y can go to the bottom and become cos y on the bottom. Okay. Now, this problem is usually a very good time that takes up a lot of time in class because this has a ton of stuff to do. I can separate this all fine and good here. So when I multiply, I get cos y, I get e to the minus y, because that would go to the bottom. Cos y would come to the top. E to the minus y cos y dy is equal to e to the minus t times 1 plus t squared dt. And I am going to give you a chance to try that on your own because, well, I want to, but I'll give you kind of a hint here. This kind on the left should stand out in your mind as the kind that you have to do 2 times of integration by parts and then add the leftover back to the other side and divide by stuff, because you end up getting them back to where you started from with two parts. Over here is a very good tabular integral one. If you haven't seen the tabular method before, this is a good one for that. So I want to let you try that one on your own. It's a very good problem, and I'll post the solution to that somewhere else. I don't think I gave myself enough room on this page, so things to do for version 2.0 of the notes. The next video will be focused on applications, and so that should be fun. I will see you then.